Hello everyone. On today's video we will be going over exponents. Okay, so we're going to start off with the product rule for exponents, but first we're just going to give a quick overview of exactly what an exponent is. There we go. Okay, so an exponent, or at least the parts of an exponent, is what we'll call a to the nth power. Okay, now the a is what we call our base. Now the n is the exponent. Okay, so really a to the nth power just tells how many times you're going to multiply a to itself. So that means if you have a to the nth power, that means you're going to have a times a times a times a times a, and it keeps on going times a, and you multiply it n times. So you have n factors of a. All right. Okay, now a to the nth power, this is what you call an exponential expression. Okay, so let's go to a couple of examples. Okay, so let's say, for example, you wanted to evaluate the following. Alright, so let's say for problem A, you have 2 to the third power. And let's say for problem B, you have 3 to the second power. And let's say for problem C, you have 1/2 to the fourth power. Alright, so let's go ahead and move that up. So to solve these, problem A, you have 2 to the third power. That's just 2 times 2 times 2. Okay, so 2 times 2 is 4. That 4 times 2 will equal 8. Okay, so 2 to the third power is equal to 8. Say for problem B, you have 3 to the second power. Then that's going to equal 3 times 3, which is equal to 9. Okay, now for problem C, if you have 1/2 to the fourth power, then that's equal to 1/2 times 1/2 times 1/2 times 1/2. Okay, so we know that 1 times 1 times 1 times 1 is equal to 1. And 2 times 2 times 2 times 2, we have 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. Okay, so that's kind of a quick explanation on exponents. Let's do another quick example. All right. Let's say, for example, we wanted to evaluate, say for problem A, you have -4 squared. And for problem B, you have -4 squared. Notice the difference. You have a parentheses around the -4 here, but you don't have a parentheses here, and that's very important. And I'll show you why you will get completely different answers for both of them. Okay, so for problem A, if you have -4 squared, then that's going to equal -4 times -4, because that squared applies to everything in that parenthesis. Okay, so -4 times -4 is positive 16. All right, now for problem B, because you don't have parentheses, you're going to approach that one a little bit different. You have -4 squared. That's just like saying -1 times 4 squared. So as you can see, your answer will be a little different. So this is just -1, and 4 squared is 4 times 4. Okay, so we know 4 squared equals 4 times 4, which is 16. Okay, so this is just 1 times -1 times 16, which is just -16. Okay, so be really careful when you have negatives and parentheses, because it can affect your overall answer. All right. Okay, so let's go move ahead to our next example. Down a little bit. Okay, so what if we wanted to evaluate 2x to the third power when x is equal to 5? Okay, so basically what they're doing here, they're telling us what value they want x to become. Okay, so 2x to the third power, remember x is equal to 5, that will just become 2 times 5, to the third power. Okay, so 2 times 5 to the third power. Okay, so all we did was replace the x with the 5. Now that third power only applies to the 5. Okay, it doesn't apply to the 2. That exponent only applies to the number its immediate left. So in this case, it's just the 5. Okay, so you can see here that 5 to the third power is 5 times 5 times 5. Okay, so 5 times 5 is 25. 25 times 5 is 125. Okay, so this becomes 2 times 125. Yep, straighten it up, there we go. And 2 times 125 is 250. All right, so let's do another example. What if we wanted to evaluate 2x to the third power when x is equal to -5? All right, so again, you have 2x to the third power, but this time x is equal to -5. So that will become 2 times -5 to the third power. And again, remember that exponent only applies to the value to its immediate left. So because that entire -5 is in parentheses, that 3 applies to whatever is in those parentheses. Okay, and we can see here that -5 to the third power is equal to -5 times -5 times -5. Okay, -5 times -5 is positive 25. Positive 25 times -5 is negative 125. Okay, so this will become 2 times negative 125, which in this case would be negative 250. Okay, so again, you want to be really careful with those parentheses. Okay, so now that you have an idea of how exponents work, we're going to go into the rules for exponents. Okay, now the product rule means you have x to the power of m times x to the power of n equals x to the m plus n. And that's when you know that m and n are real numbers. Alright, so to kind of give you an idea of how that would work, let's say, for example, we want to simplify x squared times x to the 5th power. Clean up that 2 a little bit. There we go. Okay, now if we wanted to just rewrite x squared times x to the 5th power, we'll straighten that up, there we go. We can rewrite it x squared, remember that's just x times x. So you have x times x times x to the 5th power is just x times x times x times x times x. So you had x squared times x times x times x times x times x. Okay, so x times x times x times x times x times x times x is just x to the 7th power. Or you could just use that formula up here. X squared times x to the 5th. And remember, as long as the bases match, you just add your exponents. So you have x squared times x to the 5th equals x to the 2 plus 5, which is x to the 7th. So just adding your exponents is a whole lot easier. Alright, so let's say, for example, if we wanted to simplify let's say x to the 20th power times x to the 18th power. Okay, and you can see there, if you wanted to solve it like you did up here, you'd have to write x times x times x. You have to do that 18 times, or 20 times. Then you'd have to do it again another 18 times, and then add all those together, and you'll get that. It's just a whole lot easier to know that x to the 20th power times x to the 18th power is just x to the 20 plus 18. Which is x to the 38th power. Alright, so what if we wanted to simplify x to the 25th power times y to the 48th power times x to the 10th power. Okay, so you have x to the 25th power times y to the 48th power times x to the 10th power. Remember, multiplication is commutative, so you can move these around. So if you wanted to rewrite them, you can make it x to the 25th power times x to the 10th power times y to the 48th power. Okay? Which means you can combine those two. So that's x to the 25th plus 10 times y to the 48th power. Now you can't combine this because remember, the bases have to be the same. If the base is not the same, you can't add your exponents. So that y to the 48th power just stays y to the 48th power. It doesn't combine with anything. Okay, so that gives us x to the 35th power times y to the 48th power. You really don't need to multiplication with variables because they just, whenever they're right next to each other, we automatically know they're being multiplied. Okay, so this would be your simplified answer. Alright, so going to our next example. Straighten up our papers here. Here we go. Let's say if we wanted to simplify, let's say 5 to the 4th power times 5 to the 7th power, and you wanted to write your answer as an exponent. Which means we don't have to actually solve. Okay, so if we have 5 to the 4th power times 5 to the 7th power, your bases are the same. So that's just 5 to the 4 plus 7. Which is 5 to the 11th power. Okay. Now the key is writing as an exponent. Means you don't want to have to go 5 times 5 times 5 times 5 times 5 and do all that 11 times, and you have a really humongous answer. Alright, now one mistake that I have seen that I want to point out so you don't make it is that you don't multiply your bases. You do not have to multiply your bases. Okay, so for example, if you have 3 to the 6th power times 3 to the 3rd power, that does not equal 3 times 3 is 9 and 6 plus 3 is 9. That does not equal that. You don't multiply your bases. But instead, if you have 3 to the 6th power times 3 to the 3rd power, that's going to equal 3 to the 6 plus 3, which is 3 to the 9th power. Okay, so this right here is incorrect. Don't want to do that. All right. So let's say, for example, you want to simplify 7 to the 5th power times 8 to the 3rd power. Okay, now remember the rule from before, the bases have to be the same. So really, this cannot be simplified anymore because you have a base of 7 here and a base of 8 here. So you can't combine them. 705 times 8 to the third cannot be simplified. Since the bases are different. Okay, so your answer for this will actually just be 705 times 8, well, 7 to the 5th power times 8 to the 3rd power. That would actually, oh, sorry about that. That would actually be your answer. All right. So now we're going to go ahead and go to our next example. Okay, now let's say, just a quick note, when no exponent is present, you assume it has an exponent of 1. Okay. For example, if you have 5, that's just 5 to the 1st power. Or if you have 28, that's just 28 to the 1st power. Okay, so you always assume when it has an exponent of 1, no exponent, it's an exponent of 1 there. So, for example, if we wanted to simplify 12 to the 5th power times 12. Okay, so really, 12 to the 5th power times 12 is the same as saying 12 to the 5th power times 12 to the 1st power. Exact same thing. Okay. Now, since we have the same base, we can combine those two. So that would become 12 to the 5 plus 1 power, which is 12 to the 6th power. All right. Now, those are examples of the product rule. Now, with the product rule, you add your exponents. Now we're going to look at the quotient rule. Oops, straight up papers here. There we go. Now, the quotient rule for exponents is a little bit different. Okay, and that's x to the power of m over x to the power of n equals x to the m minus n. And again, that's assuming that m and n are real numbers. All right. Now, the key to some of these problems is the fact that you want to remember that anything divided by itself is equal to 1. 3 divided by 3 is equal to 1. 79 divided by 79 is equal to 1. 247 divided by 247 is equal to 1. Even if you don't know what it is, even if it's an unknown variable, x divided by x is equal to 1. y divided by y is equal to 1. X squared divided by x squared is equal to 1. Anything divided by itself is always equal to 1. Alright? Now let's go into our first example. Okay, so for example, what if we wanted to simplify x to the 7th power over x to the 4th power? Okay, so first we're going to do it the long way, then we're going to do it using the quotient rule. Okay, so the long way, you have x to the 7th power over x to the 4th power. X to the 7th power, remember that's just x times x times x times x times x times x times x. Over x to the 4th power is just x times x times x times x. Okay, now what if we separated these? So that would equal x over x times x over x times x over x times x over x times x over 1 times x over 1 times x over 1. We have 1, 2, 3, 4, 5, 6, 7 in our numerator, and 1, 2, 3, x to the 4th power in our denominator. Okay, now anything divided by itself is just 1. So you have 1 here, 1 here, 1 here, and 1 here. So really, the only thing left that didn't cancel out is x times x times x in the numerator. So you have x to the 3rd over 1 times 1 times 1 in the denominator. Anything divided by 1 is just that value, so it's x to the 3rd power. Okay, which is an awful lot of work to go through. Or you can just use the formula x to the 7th over x to the 4th is just x to the 7 minus 4. Remember, again, as long as the bases are the same. So you have x to the 3rd power. So this is just a whole lot faster. Alright, so let's do a few more examples. Just straighten out my papers there. There we go. So let's say, for example, if we want to simplify x to the 15th power over x to the 4th power. Okay, so x to the 15th power over x to the 4th power. Remember, bases are the same. As x to the 15 minus 4, which is x to the 11th power. Alright, so what if we wanted to simplify? They may say simplify, evaluate, solve, either one. They're asking really the same thing. So if we have 3 to the 12th power over 3 to the 5th power. Alright, again, bases are the same. So we're good. Both have a base of 3. So that's just 3 to the 12 minus 5. Okay, so that's 3 to the 7th power. Alright, so what if we have one that's a little different? So we wanted to simplify, say, negative 5 to the 18th power over negative 5 to the 7th power. Oops. Okay, Okay, this is where those parentheses come in handy. You have negative 5 to the 18th power over negative 5 to the 7th power. That's equal to negative 5 to the 18 minus 7 power. So that's just equal to negative 5 to the 11th power. Alright, now do one more example here. What if we wanted to simplify, say, negative 7 to the 10th power over 7 to the 8th power? Actually, this one you couldn't simplify, at least not yet, because you have two separate bases. So base of negative 7 in your numerator base of 7 in your denominator. So move that up a little. Okay, now when you learn the power of a product rule, you'll be able to simplify this. But just based on what we know now, you can't simplify because the bases are not the same. One's a positive, one's a negative, but these you can't simplify right now. A little later, yes, but not right now. All right, so let's go ahead to our, cannot simplify yet. Okay, so remember, those bases are not the same. All right, so let's move on to our negative exponents. Okay, so for your negative exponents, you have x to the negative m power equals 1 over x to the power of m, and 1 over x to the negative m power equals x to the power of m. Okay, so for example, we wanted to simplify 2 to the negative 3 power. Okay. So by simplify, most textbooks and online, I guess you could say online programs, just means they don't want any negative exponents. Okay, so 2 to the negative 3 power. Remember, when you have a negative exponent, all you have to do is make it 1 over that exponent and make that exponent positive. So that's equal to 1 over 2 to the third power. Okay, and we know that 2 to the third power is 2 times 2 times 2, which is 8. So this will equal 1 over 8. Alright, so what if we wanted to, or what about if we wanted to simplify x to the negative fourth power? X to the negative fourth power. Remember, you have a negative exponent. You just put it in the denominator and make it positive. It's just 1 over x to the fourth. Okay, so what if you have a negative exponent in your denominator? So if we wanted to simplify 1 over x to the negative 3 power. So 1 over x to the negative 3 power is equal to, when you have a negative exponent in your denominator, you just move it up to your numerator. So you have x to the third power and make it positive, which is just x to the third power. Okay. So whenever you have a negative exponent in your denominator, you just make it positive and move it up to the numerator. That's how we ended up with just x to the negative 1 over x to the negative third is just x to the third power. Alright, so let's say we wanted to simplify 1 over 3 to the negative fourth power. Alright, so for this one, 1 over 3 to the negative fourth power is just 3 to the fourth power. Okay. Now we know that 3 to the fourth power is 3 times 3 times 3 times 3, which is equal to 81. So this simplifies to 81. Alright. Okay, so let's go to our next example. Let's get a paper here. Now the next couple of examples will combine both the quotient rule and the negative exponent. Combining up. Quotient rule and negative exponents. Alright, so let's say for example, if we wanted to simplify, let's say for problem A, we have 7 over 4 over 7 squared, and for problem B, we have 7 squared over 7 to the 4th. So we just switched up the denominators and the numerators. Okay. So for problem A, we have 7 to the 4th over 7 squared. Bases are the same, so that's just 7 to the 4 minus 2, which is 7 squared, which is 7 times 7, so that's 49. Okay, so let's go with problem B, where we have 7 squared over 7 to the 4th. And straighten that up a little bit. There we go. Now that will end up being 7 to the 2 minus 4. Remember, it's always the exponent of the numerator minus the exponent of the denominator. Okay, so we end up with 2 minus 4, which is 7 to the power of negative 2. Okay, So whenever we have that negative exponent, we move it to the denominator and make it positive. So 1 over 7 squared. We know that 7 squared is 49, so we have 1 over 49. Alright, so let's say for our next example, we want to simplify, say for problem A, 5 to the 4th over 5 to the 7th power. Let's say for B, you have u to the 5th power over u to the 12th power. And what I want you to do is press pause and work on these two yourself. Alright, so assuming you have this one all solved, for problem A, 5 to the 4th power over 5 to the 7th power, bases are the same, so you have 5 to the 4 minus 7, which gives us 5 to the negative 3 power. Okay, you have a negative exponent, so that becomes 1 over 5 to the 3rd power. We know 5 to the 3rd power is 5 times 5 times 5, which is 1 over 125. Alright, now for problem B, we have u to the 5th power over u to the 12th power. That's just u to the 5 minus 12 power. Is u to the negative 7th power, which becomes 1 over u to the 7th power. Alright. Go to our next section. Oh, let me grab some more paper. Sorry, running a little short. Now we're going to look at exponents of 0 and 1. Now we have exponents of 0. Anything raised to the power of 0 is equal to 1. Okay, now when you have exponents of 1, we actually covered that earlier. Anything raised to the first power is just equal to that value. Boy, let me clean up that 1 a little bit. There we go. All right, so for example, what if we wanted to simplify, say for A, you have 3 to the power of 0. Say for B, you have 3 to the power of 1. Let's say for C, we have 4 to the power of 0 plus 4 to the power of 1. Okay, so let's go ahead and get all 3 of those. Okay, so 3 to the power of 0, anything raised to the power of 0 is just 1. Okay, so for B, 3 to the first power anything raised to the first power is just that value. Don't have to do anything else to it. Now for C, we're going to combine both of them in one problem. So 4 to the power of 0 plus 4 to the first power. Okay, you notice there, anything raised to the power of 0 is equal to 1. So you have 1 plus, and anything raised to the first power is just that value. So 4 to the power of 0 plus 4 to the power of 1 is equal to 5. Alright, so let's go ahead and do another couple of examples. What if we wanted to simplify, say for problem A, negative 2x, and that entire thing raised to the power of 0. And let's say for problem B, we have negative 2x and just the 0 there. Again, just showing the importance of parentheses and knowing how to specifically solve them. Okay, so for problem A, negative 2x and that whole thing to the power of 0, that 0 applies to everything in those parentheses. Okay, so anything raised to the power of 0 is just equal to 1. Now without those parentheses, you have negative 2x to the 0. That 0 only applies to whatever's to the left of it. So really this is just like saying negative 2 times x to the power of 0. Okay, we know anything raised to the power of 0 is equal to 1. So we have negative 2 times 1, which is just negative 2. Alright, so let's go ahead and do another quick example. We wanted to simplify, let's say 12 times n to the power of 0 minus 18 times m to the power of 0. Okay, so two different variables, both raised to the power of 0. Alright, so if we have our 12 times n to the 0 minus 18 times m to the 0, remember that 0 only applies to what's to its immediate left. Now if you would have had parentheses around the 12n, that whole thing would just equal 1. But you only have the 0 exponent next to the n. So that's just like saying 12 times n to the power of 0 minus 18 times m to the power of 0. Okay, so there's no parentheses to keep all of those together. Okay, so anything to the power of 0 is equal to 1. So this is like saying 12 times 1 minus 18 times 1. Okay, so really that just becomes 12 minus 18, which is negative 6. Okay, so be really careful about problems like this with no parentheses. At first glance, well, okay, that's 1 minus 1, which is 0. Nope, you have to actually think about where that exponent is and whether or not you have parentheses. Okay, now hopefully that made sense, and I will see you on the next video.